Hello everyone. I've done another project. I don't know what to call it. A messenger, remote messenger. I don't know. Basically, you can use your anything that has a web page. Basically, on your home network to send messages or something to this thing here. It's made up of four. Let me just remove one. It's made up of these 8x8 matrix LEDs. They've got 8 pins there and 8 pins there, and they connect to this chip here. Now, I don't know if you can see that. Let's see if I can zoom in on it. Because mine is not. Oh, it's upside down. Anyway, it's one of them chips, and it plugs onto. Well, you can get these boards just as one board, and you've got your pins going in. Let me just get back down to this sort of level. Zoom in again. There we go. But this is a board with like 4 stuck together in a row. You could cut them all apart and then just use connectors. But I'll leave it as 4. 4 is a good size to get something written on and puts things on. These, you'll notice that these have like a tab on one side, and that sets the orientation. Oh yeah, what are these called? Well, oh right, yeah, that's what I was going to say. What this thing was called? Right, this thing is called. Right, everybody sees them, and you use. I'm not going to use a library, but what you do is you normally use a library for the Max 72 whatever, because this number can be different. But actually, on this one, it's a clone. Well, if you want to call it a clone. And like I say, I'm not bothered about clones. They do the same thing. They're cheaper though. Which has got this on. So the numbers are the same. It's 7219, except it starts with the manufacturer GC, whereas this is from the manufacturer Max. I forgot what it stands for. Actually, I'll have to bring up the. Oh, right, yes. What do I need to do? Yeah, I should have brought up the. I should have got my. I don't know. All right, yeah. I'm trying to think out where I've put all the data sheets. And yes. Here we go. Let me just. It's totally messy up. You know what my videos are like if you've seen any of the others. Anyways, what we got? Is it this one? It better be. Where is it? Let's get that to fit. Oh right, no, I've got the. This is the LED. This is this bit. Here we go. It's this thing here. I've got a number. I put a number on. There we go. Look there. It's 1088AS. 1088AS. Yeah, there we go. So, right. I was looking for the the chip, but I've got this. It's the data sheet for that. So what that is an 8x8, and you can get them in different sizes. And basically, it's just a load of LEDs all wired up like so. So depending on which two wires you light up, it lights up the various LED. And so what this chip does, this chip over here, it multiplexes the LEDs, so you get the impression that some are on and some are off. Right, let's see if I can find the right datasheet this time, and I'll see if I can find the chip. Where are we? Oh, where's my browser? Right. Where did I put that then? Oh, let's just do a search on the internet. It's easier, isn't it? So, I'll do it over here. You can watch. What did I call it? It's the Max, isn't it? It's that one there. I want. Let's do a search for that. Go datasheet. Yeah, there's one datasheet there. Is that a datasheet? Yeah. Has it got a datasheet? There's a datasheet. Let's see if we can get that. There we go. And now we've got a datasheet. Okie dokie. Let's get it a little bit wider. Yes, so normally it's this, and this is datasheet for the Max 7219. But actually on this board there's 4 of these, and what they do, they are actually for the 7-segment LEDs. Well, it's actually 8 segments, but it's the numbers are made up of 7 segments, and you have a dot. Let's have a look. It must be somewhere around here somewhere. I'm sure there's a picture. There we go. Yeah, there we go. 7-segment LEDs. So you got the 7 segments, and you got your decimal place. So you got 8 LEDs, and that's what this chip's for. It's for doing that. And inside that chip, you've got a bit of decoding, so you can actually send stuff to it. But we're not going to use it as that. You see, so you got like, if you look at this register here, and you set it as 1, it's supposed to give you digit 0, which would give you 1, 2, 3, 4, 5, 6 LEDs lit to give you a digit 0. Well, because we're using one of these. Oh, and yes, this can actually. Is there a picture of that as well? Yeah. Oh, there we go. This can actually control one of these 7-segment displays with 8 actual digits on. So you've got 1, 2, 3, 4, 5, 6, 7, 8. So this one chip can control 8 numbers basically in 8 decimal places. But because we're using one of these, which is an 8x8, each row is used as a segment. So you've got your 7-segment display and your dot, which is your 8 LEDs along the bottom there, and this next LED number is your next row of LEDs along the bottom, and then we've got our next set of LEDs going along the bottom. So basically we've got 8x8, so you've got 8 and 8, if you get my meaning. And that's what this chip does. But because we're not using that, we're not using 7-segment displays, we're using 8x8 LEDs. Oh well, anyways, let me just stick this back on here. Without bending the pins. There we go, it's on. There we go. Like I say, this board is made so that they all fit neatly together and you can't see the joins. But you got to watch out. Well, I did get a board with the wrong LEDs. are imperial and there are metric, and so your metric hang on, where's my ruler? So yeah, so that would be, if it was metric, it would be 1 2/10, but if it's imperial, it's actually 32 mil by 32 mil. So you can't get the imperial to fit a metric board. So just that's why I got some of these cheap. What's next? Right, I've done that. So I've explained why that driver drives the LEDs, and it's not where. Oh, am I showing the right page here? Because yes, I am. Right. Yes, and we're not driving 7-segment displays. We say, you know, and what I wanted to explain was each line here on here is the pins for the a 7-segment display, because it uses 8 LEDs. Right. Where next? All right. Yeah. So and these are 5 volts. Hang on, let's bring that like that. Right. I'm going to use one of these. There we go. This is the where are we? I've written it. Yeah, it's the ESP 8266, and these run at 3.3 volts. Well, the data pins. Well, yes, they run at 3.3 volts, but this runs at 5 volts. So when I plug this in, I've connected to. Can we zoom in on that? Let's try and get that there. Right, can you see V in and ground? So we've got ground, and V in is the voltage in on the USB. So when I plug the USB cable in, we're going to get the V voltage in voltage there from the V in. Let's put it the right way up. There we go, V in, and you can see there. So I've taken the 5 volts from the USB, which comes in here and goes out here. So this is actually going to be connected to. That's upside down again. Right. So here we go. Yeah. So that's connected to my VCC and ground on this, so that gives it 5 volts power, because I've come this wire here, this wire here on the V in is the 5 volts from the USB, so that gives it the 5 volts. Where are we? That gives it the 5 volts power it needs. The other three pins are data pins. So we've got the data in, got the cable select, and we've got the clock. And they just come from these 3 pins here. So I've got my D5, D6 and D7, which that is the D5, D6 and D7 is the port D5, port D6 and port D7, because they're coming from port D on the ESP32. Not 32. What did I say? ESP8266. Yeah. But they're only 3.3 volts out. The logic is only 3.3, but that is enough to flip the logic on this. So we can just connect them straight in there. I'll do the pin connection in a minute. Well, sorry, I'll do which one is which on here in a minute. Where's my? Let's get some. Yeah, that's about right light. Right, yes. So if I come back now to this, Right, this is the firmware for the ESP 8266, and what I've decided to do is, right, if you can imagine this microcontroller on here, it's very powerful. It's got plenty of memory and stuff. In fact, I'm going to put. Let's have a look. Wrong button. Where it was. Right. Right. So forget all this. Forget these. That's all to do with Microsoft Visual Studio. And my credentials, that's where I keep my password and Wi-Fi information. But we have a font file and we have a data folder, and basically I'm gonna have this. What was I saying? Oh yeah, that's it. Yeah, it's got plenty. This microcontroller's got plenty of memory. So, rather than this microcontroller doing all the work, we'll have the device that's actually connected to the Wi-Fi of this module do all the work. That is your web browser. So the web browser, when you because this has got lots of memory. This is a good way to sort. Well, this is why I did it. This project is to show that the microcontroller, this microcontroller, does not have to do all the work. This does not have to work out what time it is. You see, you'll notice that there's no real time clock on here, but we're going to have time displayed on this device. But the idea of this project is to show that all the work done can be actually done on the client, which is your computer. Oh, hold on, someone's at the door. Where's my pause button? And I'm back. Oh, right, yes. So what I was saying was, we can have, say, your computer do all the work, and all this microcontroller has to do is display light up the LEDs on the display. It doesn't have to do, so if you send in the time, it doesn't have to get this doesn't have to get the time or whatever. All this has to do is display the LEDs it's told to. So that's all this is going to do. All the work is actually going to be done on the PC connected to this, or it could be your phone, your mobile phone, or a tablet, anything with a web browser. It's the actual web browser that's going to do all the work, and that will be actually on or your PC or phone or whatever, which has got a lot more power than this. And so basically we have these files here. This is just an icon. It displays the icon on your web browser. This is the index page. This is what you see on the web browser. And then we've got, this is just a JavaScript for the arrays. This is the JavaScript for my fonts, which I'm going to use to display on this. So all these, and this is my script, and this is the style sheet for the index page. And the script here is all the code, which basically is just on this server of the ESP, and when you connect to the ESP, all these files are actually sent to the main to the client, and it's the client that uses all these scripts in the JavaScript to do all the work, and so none of the work is actually done on this. Once you connect to this module, all this information is sent to the client to work with, and all the instructions and everything are actually in these files. So let's have a look at some of the code. So I've got it here. So on the ESP8266, I've set it up so you can have it in 3 modes. The best mode to have it is, or forget this. What you need to do is you need to tab comment that out, and basically what that file is there is my credentials, which will be this here. So what you'll need to do then is uncomment that out, and then what you'd put is your local network name in there and the password for your local network in there. Basically what it is that's what's in my credentials header file, but I've put them in a separate file so I don't accidentally show people, and so people can't connect to my computer. Okie dokie. So yes, that's what you do that's what you do when you comment that out. And there's, well, if you ever want to look at the code, and there's some serial output for debugging, so you can uncomment that if you like. But there's 3 types of connection. There's access point. There's access point with a password. Now what these 2 are, well, they're the same thing, but one with it is with a password and one with it is without the password. Is you connect to the server on the module, so you connect direct to this module. You don't connect to anything else but this. And doing that, it will give you will have this IP address, because you're actually connecting to the server direct. This I've given it here what the IP address is on the server, and you would open a web page at that IP address. But if you have your home network with Wi-Fi, which is the better thing, so most people doing a project like this, we can use this access point as a station. So what this does in this mode, when you turn this Wi-Fi on, it actually connects to your home network via Wi-Fi, and what it does, it gets assigned a web page IP address. So when this connects, it will connect using this here. It'll connect using your local network name and your local password. Then once it's connected, your network will give it an IP address which to use for the web page, and that will be displayed on this. I'll show you it displayed on this, and that's what you can either, if you have this debugging on, you can connect serial and it will give you the IP address it's been allocated. But if we're not using serial and we're just using this as a module, standalone module on its own, basically, we just plug this into a USB power supply, and then we can connect on your network the IP address it's being given, and send information. It'll get a bit clearer later on. I might be rambling a bit, but I'm trying to cover everything. Basically, there's no code in it. The code that goes to this module, there's nothing in here for it to do anything except for display at the beginning when it boots up is the IP address it's being selected. So we'll leave that at that. What we'll do is, these are the libraries that it requires, because it's the ESP8266. It needs the Wi-Fi library. We're also creating a web server, so it needs the web server library, and we're sending information to it using JSON. Now this is Java. I forgot what. I forgot what JOS. It's JSON. That stands for JavaScript. JS stands for JavaScript, and I think it's online notation. I think it is. I forget. Let's see if I can. Let's have a look. JSON. JSON. Oh right, sorry, it's not online. It's JavaScript object notation. So what it does, basically, what this JSON does is, say if you have some variables. Well, I've got one down here. Let's have a look. Right. So this is my display buffer. Right. So my display buffer has got well, it's a 32 by 8 bytes display, and these are bytes basically. But what it does is, when you're working over the internet, things go as text. So basically, the JSON is, what it does, it converts it to a form of text that can be converted back and forth between objects used in code. And then we also have the FS header. Actually, why is that local? I don't know. I think it shouldn't be local. We have the FS header, and that is for the file system. Now then, what's that? I forget these. And I'll no. Well, I wish it. Yeah, I forget. I'll remember in a minute. Where are we? All right. This is why I do a lot of comments, because my memory is useless. So, let's go to setup. I'll refer to it there somewhere. Do I? No. Right. Yeah. Yes. Right, there we go. The SPI flash. So it's SPIFFS. It's that, the SPI file system. So we need somewhere to stick these files, which you keep in a data folder, and then to transfer the data across in Arduino, you use this ESP sketch data upload tool. And what that does, it puts anything that's in a data folder onto the module. It puts it onto the module in the into the SPI flash filing system. Basically, it's some memory on the you talk to some flash memory on the SPI. Anyways, right, yeah, where am I? So yes, and we've got the wire, because we're going to communicate to this using the well, it is SPI. You could use SPI, but what I'm going to do with this is I'm just going to bit bang the data across. So basically, what we have is, if we get zoom in on that again, we've got it upside down, that right way up, upside down. So we've got the data in, and we've got the clock. Sorry, the cable select and the clock. What this cable select it does is, when this goes, I forgot whether it's high or low, but when this pin is active, shall I say, This knows that it needs to listen to the data in and the clock. The clock just tells it that's just tick tock, tick tock, tick tock. Basically, it's just telling it what to look to read this every time this goes tick tock. Basically, yeah, that's it simply. Well, a clock's a clock, isn't it? Tick tock, tick tock. Anyway, yeah. So what we're going to do here. So we need the wire for that, and I need this font because that's going to tell. Well, that's going to this font here is for the numbers it prints when it tells you what IP address is allocated. This font is so that the microcontroller knows what LEDs to light up. So when we say if it's 192, it knows what 192 looks like basically, and that's that there. So each one of these is a digit, and I think this will be number 1. If you want to alter these and make your own font up, I have got a nice little application. Where are we? Find that. There we go. Right. Yeah, with this application you can create new little fonts. So if we go full width there, you can see I've done a little. We can make something there that's like, what size is that? Oh, that's 32 by 32 there, look, you see, 32 by 32. But what we can actually do, right, so all my fonts are 6 bytes wide, so we've got like 6 bytes there. So if I just copy that, and we can see what it looks like. I'll just paste it in here. I'll just make sure my width is 6 there, so we can do like that. So all these orange bits count, so it's going to be vertical. So all my, so that is like a vertical. It goes down these numbers here. So like it goes like column and column and column. So we've got one column of 0, another column of 0, and then we've got a column of 5F, whatever that is. We'll see in a minute. Well, let's have a look. So I've stuck that in there. Well, it's going to be 1 into that because these are 0, 0. So let's just have a look. There you go. Oh no, that's what it is. That's what that one is. So that 5F is this column here. Look. So let's try this one. No, let's try a bit further down. It'll be a better number. I don't know. So if I copy that, so we got that. I reckon that's not 1, 2, 3, 4, 5. This is probably 6. Oh, right. Hang about. Those aren't numbers. Where does numbers start? Let's try down here. No, wrong one. Where does numbers start? Give me a minute. Right. I thought I had a font thing. Where's my font? I never know where to actually save my font file. Oh, maybe I put it in display. No, I didn't. Oh, let's go back on the internet. Yeah. So there's that. Let's pick that one. But that's small, isn't it? Oh, hang on. Where's our numbers? Somewhere around 49. Here we go. That's an L. I must have started. Anyways, what I was saying is you can edit these. Basically, what I've done is in my matrix font here, I've actually I've actually put some ASCII numbers and what they are here. So there's an 8. So if we go there and we look at that, that should be an 8. So clear that, put that in, and then read there's an 8. So if you want to restyle that 8, basically you can edit in here and just make it look like what you want. Basically, we could just do that there, or we could just make it more like that. If you prefer that type of thing, and then what you'd do is you would just get data, and it would give you the new data, and you could change this. You could change that for the new data and do it. So it's that simple. You could just edit it like that. Only, like I say, if you want to make it more sort of like that, basically, whatever you do, you can edit it, then get data, and there you go. You just copy that. You just click copy all, and then you just paste it in. I'm not going to because I want my font to look like it is. So anyways, yes, I've got that little application there. I found it on my web page. Yeah, my web page. Where are we? Let's go here. Go home. Yeah, my web page. Applications. And there it is. Basically, you can just download it there. Right, yeah, so I've forgotten where I'm at now. Yeah, alright, so we're down here. Yeah, that's our font header. So the other font header, which I just showed you, is for the web-based side, which was this one. This is font that gets copied across. That one there is in matrix font, that is. Right, okay. So as we go down, oh right, yes. So yeah, when you connect, depending how you've connected, if it's an access point, this is the name that it identifies it. If you are connecting. If you're connecting direct to this, via Wi-Fi, you can actually give it a name, and this is the name I've given it at the moment. You can change that. You can put what you like in there, and this is the password. You can put what you like in there as well to connect it if you want to connect to this using a password. So that is. That's straightforward, isn't it? Yeah. Oh, right, yeah. Just remember your password, if you change it, it has to be at least 8 characters long. That's the thing about these Wi-Fi things. I don't know if you know about it, but it's same for the ESP32 as well. If you're changing the Wi-Fi password on the data thing, because if you go to when you upload, you'll upload the same for whether it's the ESP8266 or it's an ESP32. You have this bit here where you can actually change the sketch only, or you can have the sketch and Wi-Fi settings, or all flash content. So if you're ever changing the Wi-Fi settings, either have this one or this one connected, preferably just this one. If you have this one chosen, it's going to delete everything that you've uploaded here using this little application. So once you've uploaded your data using this, you do not want to have it on this, because if you upload your sketch, it will wipe all that you've previously uploaded on this, basically. So just make sure you check this arrays settings, so that if you change anything to the ini file, you know, the ino file, shall I say? Is it? Yeah, ino file. Make sure that you're only changing the sketch. Have this if you've been using your ASP for another project, so that you're starting from scratch when you first upload stuff. Once you've uploaded it, change to only sketch, and then so when you actually upload this, use this to upload all these files here, that you don't erase them when you upload or change a sketch. I think that was pretty clear, I hope. Yes, so we've got past there, and that's the local thing. I've done it. Right, these are just paths for the spiffs. The SPIL file, or whatever it is. It's the spiffs. It's these files here. See all these files here. You see they've all got a name in the data folder, which is going to, if it's in the data, just in the data folder, these are all actually in the root directory, so to speak. And so basically it's slash. So what all I've done is I've made a definition for each of the paths for each of these files. So what I do is I use these definitions later on in the code. It's just that if I change the name, I can just change the name here, and the code automatically sorts itself. But those are actually in the setup. So if we go down into the setup, right, so we're not using that, and we're not using that. Am I out of the setup there? Am I still in setup? No, yeah, I'm still in setup. Right, so it's these here. See, I've got the index, and I've got the fav icon. So this is the server stuff. This is telling, when we talk to the server on this module here, what we do is we send like a command, so we can ask it for this, and what this does here, it says if our web page asks for the fav icon, it looks in the spiff at that path, and it sends it as an image X icon. So it's telling it, it's going. This is telling it, the server, to send this fav icon as an image in the X icon format. And similar. This is just refresh. You've just logged onto the page or whatever. It sends the index page, and it just sends it as text in HTML. So it's sending it. It's sending the HTML code as text. I've just pulled a wire off there. Hang about. I'm fiddling with this, and I've pulled a bloody wire off. Right. So make sure I get that the right way. Right. Yeah, that's that done. Yes, and the same goes for the others. So when the web page loads the index, in the index. So let's have a look at the index. Here's the index. Not a lot to it, is there? If we just go to design, that's what it looks like. And just close that for now. So basically all it's doing, once it loads, it'll ask for the thing. And where was I? Script. Oh, that one. Yes. So when it asks for the index, so which is this it's this page. It's index. The document type is HTML, so it's all in HTML code, and it's all sent as text. So that's what that does there. So it sends it in it tells it it's HTML code and sends it in text. Then we have the style sheet, right, for styles. So if we look at the style sheet, there we go. We can see that's our style sheet. That's what makes the buttons all look what colour they are, whether they're rounded, and all of my LEDs look like LEDs. It tells it how to draw things, pretty pictures. But you've got to remember, it's your computer or whatever's connected to this, that's doing all the work. All this code here is not done by this microcontroller. It's all done by your web browser on your device that you're connecting it to. Yeah, so that's what that does. If it's looking for that style sheet, which I've asked it to do, where are we? Oh, there, link. There we go. There. So I've asked. There, you can see that this is a link to a style sheet, and that's what it's called. And so what happens is the index page here wants to know where this. We'll ask the server for this style sheet. So it'll ask for style CSS, and so what the script, the thing does. So when it asks for this there, so it's asking for it. The server is going to look in the spiffs, and it's going to look at the path for the styles. This is the path which I remember I told you was up here. There, so my style is style sheets. That's what it's called there as well. And it sends it as text, and it sends it in the code of a style sheet. And so same here. So this is as JavaScript. That's as JavaScript. So these are the other three files, which are these three files. Oops, hang on. These three files. Right. So yeah. So where was I? We was down to the. Oh yeah, I was talking about what I did there. That's just version 1. And then I've just made some definitions. Right. So if we look at the data sheet for the chip that controls all the LEDs, which is the Max 72 whatever it could be, the chip on here, the way you tell the chip to do something is you set a register on the chip. It's a part of memory on the chip. Let's get the is it on this one? No, must be on this one then. Right. So is it? No, that's the thing. Oh, there it is. There, yes. So on this chip we have. Registers. Right. So is that as far as I need to go? Let me just scroll. Oh yeah, it is. Yeah. So we come down here. There are all the pins, and we can see the pins, and we've got the registers in here, and we give them values. This is how the serial. This is how we send. When we send something, we just send it the address. The first byte you only uses the first 4 bits, and the second byte is the data. This address is the address of the memory. This is the part of the memory that we're going to change, and we change it to whatever we send with the second byte here. So basically, what is our addresses? So these are 15 to 20. These are all to do with the actual data. And then we've got our first 4 bytes. Oh no, sorry. These are the first 4 bytes that we don't use. Hang on, wait, go back there. There we go. These are the first 4 bytes. We don't use them, so we don't use them. That they could. Hang on. They could be anything. It's the last 4 bits of the byte. The lower, least significant bits of the byte. So we've got address 0, address 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. And whatever we set these, when we send address to say address 2, we send this value. Hang on. Oh, it's not doing it. But anyway, we send that value. We send a value of 2, and then it knows that we want to alter address 2, and then we send what we want digit 1 to do. We say on or off. That's it. Okay. And so yeah. So what we do is, let's look at the code, shall we? Yeah. Oh, let's go back. So basically what I'm doing here, so my clock, this is the pin number I've used in definition. So for my clock pin, which is on here, this clock pin and thing, on my on here, what did I say they were? That's these 3. You can see, that was it. Was it D5, 4, 5? Hang on, I can't see. D4, D5, 6 and 7. D5, 6 and 7. And as I said, the D stands for the port on the chip, basically. So, yeah, D5, 6 and 7. But the GPIO pin is 14, 12 and 13. And that is the number that we're giving them. This is 13, this is 12, and this is 14. Actually, I've got a picture somewhere. Where are we? If I go to my Arduino, there we go. Yeah, that might help. Yeah. So what we've got is 5, 6 and 7, won't it? Which is GPIO 14, 12 and 13. And it's these GPI pin numbers that Arduino uses. So it calls this D14, this D12 and this D13. It is not these numbers here. These are port numbers. This is port D5, port D6 and port D7. The digital pin number is the GPI number. Anyways, it all depends which software you use to program your thing anyways. So if I was using the actual IDE for the ESP8, is it 8266? If I was using some other IDE, I would probably be writing it down as port D, pin 6. Right, so where am I? I'm getting there in the end. Getting there. It's a long video. Yeah. That's the pin numbers. I've written them as what they're written on here, so you can see D5, 6, and 7. But that, like I say, and then we come back to the registers. So I want to put these into something I know, give them a name, rather than use the hexadecimal numbers, which we can use. It's quite fine, but what I want to do is to say, if I want digit 1, well, actually, if I want decode mode, if I want to know decode mode, what I can do, I know that's that value is 9. What we can do is I can define decode mode as 9. So if we look, have I done a decode mode? Oh yeah, I have. There we go. Look. So these are my command addresses that I'm going to be using. I use decode mode, which is 9, and I use intensity. So rather than use like 10 for and try and remember 10, I can use this instead, basically. So I've defined the values for, I've put them into English basically, and also values, so like an off and on. Actually, that would be better written back down there. Yeah, put it that there. So we've got value off, on, which is these. No, not them. No. What am I talking? No, on and off. On off is 0 and on is 1. That's what that is. I'm just using them as booleans, shall I say? So rather than use a boolean on and off, I've used a value off and a value on. And these are like the total number of 8x8 devices. So what I'm using here, I'm actually where are we? You can see I've got 1, 2, 3, 4. I'm using 4 there. So this is my total 4. My intensity. So I haven't got these. I'm not lighting the LEDs up that bright. They're pretty low actually. So that's for the brightness and the height. The height of an 8 matrix is 8 because we've got 1, 2, 3, 4, 5, 6, 8, and I've got the width, which is 8. 1, 2, 3, 4, 5, 6, 8. Yeah, and that's my character start. Right. So when I'm doing fonts, sometimes I might want to save a bit of memory. You say if you're just doing the numbers, then you can start where the numbers start. So if we look at this, what I could do is, if I was just needed these numbers, what I would do is I would start at 48. But I'm actually starting here at ASCII character 32. And so, where am I? There we go. 32. But my character start, I'm actually at 32 there, so I'm at position 32. That there is hexadecimal 32. It's not 20, it's 32. And and how many characters have I got in my font? I've got 126 characters in my font. So it's the position of the last character, which is 126. That is hexadecimal for 126. And my character width. So it's easy to remember character width, then remember I give it 6. So that's how many characters I've used. So in my font I've used 1, 2, 3, 4, 5, 6 columns. Okay, so we're down to there. So that's my definitions anyway. And you can see that I've drawn. I do like to sort of like visualize what I'm doing, and you can see here this is this matrix here. So we've got our first 8x8, our next 8x8, and our next 8x8, and the next 8x8. Now the way the chip works, this chip, not that chip, the chip in here, which is the max 72 whatever, is when you send information, you pick a line. Now what you're actually doing is that, like I said, the chip, let's find the thing again. Yeah, the chip is actually designed for the 7-segment LEDs, but it can control up to 8 7-segment LEDs, so we can control. Hang on, there was a picture here, wasn't there? I'm sure there was. Yeah, yeah. So there's a picture here. So what you do, because each one of these dots is one of these segments of a 7-segment LED. God, I can't say that fast. And we can have up to 8, depending which number you wanted to change on here. Here, you tell it that first. So what you would do is you would tell it which digit you want. So whether it's this bottom row, the next row, that row, that row, or that row, which is basically saying whether it's that number, that number, that number, or that number. And then we send the actual value of that number, and then it will light it will light the LEDs of the number, which is a collection of these 7 segments, and plus the decimal point if needed. But basically, it's lighting so many of the LEDs are being lit, basically. Right, have I got that right? Yes. So we do a row at right. So like I say, what I like to do is like to draw it out so it helps me remember. Now the first bit send. Say we were only doing this one here. Hang on. Say we were only doing the first one, like that. What it would do is it would send this bit first, then that bit, and then that bit. So if you've got to imagine it coming in from the left and going, and every time it sends a bit, it pushes it on one, and pushes it on another, and pushes it on another. But it does it on this row, because what we first do is we say which row we're going to do. So whether it's this number, that number, that number. But because we're doing LEDs, we're saying it's this row. But rather than go to the next row after that, so I'll go, well, you can do it either way. You can go that row, which you put this bit in first, then that bit, because it comes in and it gets pushed to the end. Like I said, send this bit first. Now the way you can do it several ways. You can do it several ways. You can keep changing rows. So, well, no, you can't. You do a row at a time. So basically, if I want to fill this in here, then I would have to send it in from this end, and I'd have to keep pushing it down until this row got to this end. So basically, I am sending the bottom row of all 4 segments at a time, and then I move to the next row, and I push all the 4 segments in at a time, and they all get pushed in from the left, if you can see. So if we look on how I do that, that's all my setup. I don't need to be in there. Oh yes, I'm in setup. No, I'm not. One moment. Setup. Just close that down a bit. There's my loop. Right. Transfer matrix. There we go. No. Yeah, that's it. Yeah, so what I do, so there's my buffer, and what I do is I change all these values of this buffer, and then I send it. We've got like a for loop inside a loop, so we've got the heights, so we've got the 8 rows. This is 8. You can see there that that's 8, the height of my matrix device. So we do the like one row, then another row. But what we do is we've got another for loop in it, which is the me total, which has got the 4. So I have to do 8 4 times. So basically I've got my width there. So there's another for loop in there. And so basically what we do, like I said, is a bit bang thing. So basically we change everything in our array to whatever value we want, and then we send it in. This one goes in first, and then we keep sending the bytes in, go to the next row, send all them bytes in, then go to the next row and send all them bytes in, and then go to the next row. And so that's why we have like a 4. We have this 4, this next 4, sorry, we have this 4, which is this 4 of 8. So there's 8 4 8 times. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Then we've got our total, which is 4. So we repeat that 4 times. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, 1. That gets us to here. And then we go our height, which then we then start repeating the same thing on this row. We do the 8 4 times. Anyways, we just I'm just saying we do that bit. We just keep shooting them in one at a time. Anyways, I don't think I explained that really well, did I? Anyways, that's what I do. Let's move on to the web page. So we've got our index, and if we look at that, what I've done is, let's view that design. So this is what I've left in the memory when it turns on, and what I've done is I've done some little buttons here, and we've got a draw and erase as well. And we've got send text. So this is a web page that loads up on your actual device, and whatever you change on here, it will send to this device. Anyway, let's try it, shall we? That's not that one I wanted. That one. Right, let's shorten that to there-ish. So that is what's going to. So once we connect to this and the server sends all the files, that's what's going to get sent to your device. So what I can do is, let's go down here. Let's plug this in. So I'm just going to plug this in. All this USB is putting power. I can just put 5 volts to these 2 pins here, or we can get 5 volts from our USB. This is not sending any data or talking to it. We're not using the serial or anything. This is just using the power coming out of the end of here to power this device and power this device. That's all it's doing. Once we plug it in, now then, let me turn this light off, so hopefully we can see what's going on there. There we go. So once I plugged that in, it came up with 4 numbers. So what happens is we put power, the server on the server on this ESP module connects to my local web page, my local network, and our local network assigns it an IP address. So if I just reset this again, so I'll just press reset, and then what this will do, it will come up with the 4 IP address numbers. So 192.168.0 and 138. So now I know what IP address this has connected to. And what I can do now is I can connect to that. Do I need that? I don't need that. I don't need that. I don't need that. I'll leave them two up just in case I need to come back to them. I doubt it. So let's go to 192.168. Oh, I've already got it there. 0138 there, look. And let's press enter, and there we go. And you can see whatever is on here is on here. So let's just do some chevrons. These are just preset buttons. But what you got to remember, all the work is done on here. It's on this web page. None of the work is done on there. This processor is doing nothing. All this processor is doing is showing what this web page tells it to, and also all it's doing is sending this row of information, that row of information, and that row. So it's just sending an array of 8 by 32 to this to the ESP, and the ESP just displays that array on there. So the only work this has to do is display what that array has been sent to it on this display. It doesn't have to do any calculating or anything. It's just, hey, this is my array, put it on there, and that's what it does. So if I go to chevrons, you can see it's displaying these chevrons. If I go random LEDs, you can see that it's exactly the same as the. Let me just. I'll try and slow that. Well, I'll stop that. We'll go to draw. Right. You can see it's exactly the same as what's on here. All this is doing all the work. All the random LEDs are being done on this display here, and then all it's doing is sending that array. If you imagine this is all columns and this is an array, it's just sending that array direct to this display. I wonder if I can get colour better on there. Let me just. Is that better? Try a bit. No, that's not good. I've really messed it up, haven't I? That looks a bit better. Let's try and get on that. Yeah. Yes, and this is scroll. So whatever's on here, this will scroll it all across. And you can see it's exactly the same as that there. And we can display time. Now, you might think, how can this display time? And remember, all this is doing is displaying what is on this screen. So it's actually my web browser that's actually getting the time, and then it's just telling it and it's just telling this ESP what LEDs they are. So let's just, I'll tell you what. Let's go. Why is it doing that? There we go. So yeah, so you can see the clock's right. It's because it's getting basically this is getting the time from the internet, because this is on my computer. My computer gets the time from the internet, and so that's what time it's displayed, and it displays exactly what's on there. I can clear display, just clear it. The power on and the power off, right? So let's just go to random display. If I go to power off, it's still displaying random numbers, but what that power off has done is sent a command to this display, and it's turned off the power to the LEDs. That's all it's done. If I turn it back on, all it does is turn the power on. So if I go, let's go draw. Right, so it's stopped at that, and then on this left hand side I've put draw or erase. So what I can do is I can erase these, and I can erase them. I just go over it like that. Right, let's just draw some in. So let's just draw some. There we go. And let's turn it off. Oh, actually, I forgot to add that to my draw thing. All right, but anyway, they're still there, and if we go power on, it's still there. It should have gone like this: power off and power on, and it'll still show what is there. That is something I've just found that now. If I go draw and erase, so if I erase that. Oh yeah, and what you can do. Oh, like I say, whatever. If it goes scroll, all it's going to do is just scroll that along, and we go back to draw. I can draw things in again. Oh, I'm going to erase. Yes. So yeah. So basically, what you can do is you can put this in a room somewhere, and what we can do, and as long as it's powered, that's all it is. Put in a nice box or anything. Oh, I can't use my phone because I'm using my phone as a my phone as my camera. I'm filming this with my camera. So what we can do is, let's have a look. Move that across a bit. No, let's move that. Excuse me. Let's just move that down. Oh shit. Right. Okay. Yeah. So what have I just done there? Oh, I've moved that out, haven't I? Never mind. Yeah. Right. Yeah. So I'll move that down there so we can see a bit more of this. What I've got is my tablet, and my tablet's going to connect to my local network once it decides to start up. It's quite an oldish thing. Unlock, and we go in there. We go up Chrome. Now, what I'm going to do is I'm going to close. No, what I'm going. Right. Okay. Modern web browsers now. If I go to here, right, what it'll do is it will put that one to sleep. Okay. And so this won't be activating, but so because I want to connect with this one. So if I type in, what the hell's, unfortunately Google Plays, okay, yeah, stop, whatever. Right, I want to put in that, right, so it's got numbers. So we've got 192, 168, 0. I forgot what it was. I got 138. There we go. 0, 138. There we go. Let's try that. What the hell have I done there? I don't want to search yet. Google crap. 192. Is he typing that? Right. Yeah, I want an IP address. And I want. I've forgotten already. You see, my memory is useless. Was it 138? 138. 138. Right, I've stuck an IP in there. Go to that, will you? What have I done wrong? Am I connected? I must be. Yeah. Oh, it's decided to come up now. All right, yeah. Well, I think it was a Wi-Fi thing. But there, you can see that I'm on exactly the same. Oh, hang on. Right, can you see what it's doing? Right, I've got that one and that one. You see, it's trying to connect to both at the same time. So actually, what I'm going to do is actually going to close this one. So let me close that. Right, so we're on here now. And now we can have chevrons. There we go. It's a bit laggy, is this tablet like. And I can put time on there. So what we can do is, so whether you're using your phone or anything, you can have this wherever you like. And what I'm going to do is I'm going to shut this down because it's laggy and whatever. I'm going to go back to my main computer. But if you can imagine that you can either use a tablet, a phone, anything with a web browser, and you can connect once you know the IP address. So let me just try and remember how to shut this thing down. I'll just press the button. Power off. Right, that'll do me. Right, yes. So I'll connect again. Let's reopen up the closed tab, and you can see there once I refresh the thing, it goes back to the. Why is it? Let me just refresh that. Is this still running? Oh, I haven't said OK. I said turn off. There we go. I hadn't confirmed that I want to power off, so it was still running down here. So once it stops running on here, and this actually shuts down. Now I've told it to. Right, yeah, it shut down. There we go. We're more stable now. So really, there's only one can connect at a time. But it does, and you can put text in there. So like you can send text. Get rid of that. Let's try hello world. Oh, let's clear display and send that. Yeah, so basically, if you have this, you can have this somewhere, I don't know, where you want to put messages. And, oh, of course, if we put a space on end of there, and then we scroll, it'll just keep on scrolling that text. But the microcontroller is having to do is actually just send the information to the screen, to the LEDs. It's not actually doing any computing power or anything. It's not actually reading this text and sending the text. That's all done on your microcontroller, on your client, on your PC, phone or tablet. So, well, like I say, you could put a battery on here if you wanted instead, and then you can have it mobile as well, and just somebody within Wi-Fi range of your network can send a message. So if you've got kids upstairs, you can say, time for dinner, come downstairs, whatever. Or if you got the wife in the kitchen, you can send her a message, bring us a cup of tea, love, whatever. Anyways, I tended to, it was a bit of I don't know, was it? Oh, yeah, a bit of a drill. Oh, I didn't show you the code, did I? Yes, so basically this is all the code which normally you would put on the processor that would then run all the information and send it to the LED display. But actually all this code here that's doing all this is actually on your client, because you've sent this script document to the client from the microcontroller. All the microcontroller has done has actually sent this script that we're looking at now. It sent it all to the web browser here, and now this web browser is now running all this code, which is let's have a look. Outlining. Toggle. No. How to show all. Toggle. There we go. Yeah. So all this code here is being run on the client on the web browser, and not on the ESP. The ESP 8266 is not running this code, whatever you're browsing with. So at the moment, all this code is run on my computer in the web browser, and not on the microcontroller. I think that's what I wanted to say, is if you've got like using a microcontroller with a server and connected via Wi-Fi to a network, doesn't have to have all the code running on the actual microcontroller. You can actually put a lot of the work onto the device that's actually connected to it, like I have here. All this is actually run on my all this here is actually running on my computer, and the only thing that is actually running on the module is just changing the LEDs. That's all it's doing. It's just changing the LEDs to what the web browser's told it to do. Well, I wasn't sure whether to actually publish this or not, but if you've made it to the end, thanks for watching, and I hope some of it made sense. I don't know whether to make it into an instructable or not. It's quite comprehensive, but it's a nice little object. I mean, as an instructable, all you have to do is copy the files, but oh yes, the only other thing I'd like to mention about running stuff on a server. Now normally on a microcontroller like this, you have a loop. Let's have a look at the code. So what we have is a loop. There we go. This is your standard thing. Oh look, all that's in here is this. That's all it does. This server does, only the server is running on this microcontroller, nothing else. The server does everything, and if you want anything to change, you have to talk to the server. Now, the easiest way to write a program is, and you want things to repeat, you put them inside a loop. So everything inside it goes start to finish, start to finish, start to finish, and just keeps looping on and on. And that's the normal way you do things on a microcontroller, unless you get advanced and you start doing multitasking. So you split it up, so it does a bit of this and a bit of that and a bit of the other. But basically, on a microcontroller, it has to go. It has to run things one after the. Well, it does have to run things one after the other, unless it's got more than one microcontroller on it. Now, the other advantage of putting all the work onto the clients, like in my web browser, if we I think mine's got about eight processors, my PC. So it could be, all this work can be shared out between eight processors. well, it's all in one basically, but you know, it's got cores. That's the word I'm looking for. So it's got 8 cores, so it can be split into 8 and 8 things doing things at the same time. So the only thing to watch out for is when you're actually doing code, and especially in JavaScript, you have to tell it when things are done one after the other. Otherwise it will just try to do everything all at once. You write code, normally when you write code, it will just read it and do it. It will do them all, everything at once. And so if you don't want it to do everything at once, you have to sort of create your own sort of loop, and that's what I've done here. I call it TikTok. This is my main loop. It's a function that I run when it starts, and it's called TikTok. And basically, this is a simple way of making a loop. So you can see here, once the web page on load, it runs the function TikTok. And this is my TikTok, and everything is in a timeout. So if you want to run things on a regular basis, because this TikTok's just going to run and run. I've told it there, just run TikTok, and it's just going to stay and run. It's just going to keep running TikTok. But in here, I've put a timeout, and it's inside a timeout, and it runs at this interval here. And what I can do is, depending on what I want, display mode I want to do, I can change the interval. And so when it's doing this scrolling, say, it will scroll at a certain interval rate. And this is the easiest way to make things run one after the other, because what it does, it'll go down here and it'll run me chevrons. And it runs me chevrons every 200 milliseconds. So if I went on to chevrons, every time it changes every 200 milliseconds, and it can run me chevrons. Where are we? There we go, chevrons. So basically it'll just run that, and it'll run it to the end, and it'll do it. But then in my loop, because I want it to loop round, I've sent an interval of 200s, so it's going to send this, do this TikTok. It's going to run it every 200 milliseconds. So that is a little way of getting like a loop in JavaScript. Because well, if it just kept going around in chevrons, it would, if the chevrons took time to tick away, what it'd do is it'd read the code, run it, and then it'd come back to read it again faster than the delays you have inside the chevrons, and so you just get chevrons on top of chevrons on top of chevrons. I don't know whether to publish this or not. I'm going to call it. I'm going to think about it. If you made it to the end, to my rambling, and I hope you found it interesting. Let's just, the sun's come out. Let's just try and get this darker. There we go. There we are. Yeah. I don't know if anybody will find this interesting. Anyway, if you made it to the end, thanks a lot. Okie doke. I'm sure I've missed something, and I've gone on for ages. Yeah, let me stop it there. Stop. Let me stop it before I ramble too much. Okay, thanks for watching.